Hello students, good evening. Good evening, Bellary, Davangere students. Okay, I can see two Davangere JNV joining. Can I know which is it? Or either you have changed the name. And also in the meantime, students, please let me know, is my audio, is my presentation visible or not? Let me know through the text. Okay. And YouTube live students, good evening. Good evening. Okay, thank you, Bellary students. Others, let me know, Davangere students. Okay, thank you. Good evening, everyone. Keith, good evening. Okay, we'll be waiting till 6:45. Then we'll be starting our session. Okay. So wait for a while such that students join. Okay, Tirth, thank you. Yeah, so people are joining. Okay, students from North Canada, good evening. So I'm launching the technical poll. Okay, I'm launching the technical poll. Please answer the technical poll. Okay. So the poll is very important to understand. I know you guys have told using the chat box also, but please answer through the poll too. Okay, good. Sweetie, good evening. Okay, so most everyone has answered. Thank you. I'm ending the poll. That's good. That's good. Okay, so welcome to today's session, students. My name is Samanvit, your physics faculty from Avantifellows. I hope everyone is doing well and good. Okay, how are you all? Let me know. Everyone is well and good. Every student had their breakfast, everything. Just a second. Let me just pin myself. Okay. Okay, good, sweetie. Nice, nice. Very good. Now, okay. So we were talking about what? Newton's laws of motion, students. So in today's class, what we are going to talk about? Today, first of all, we'll quickly go what we studied in the last class. Okay. See, there are certain concepts that is still left, but I'll be continuing it. See, those concepts are what to be understood using numerical based. So after completing all this concept of frictions, other things and other types of frictions, then we'll be going back to those things. Okay. So today we'll be quickly recalling everything that we studied in the last class. Then we'll talk about friction, students. What is this friction? Where does it come from? Okay. The direction of friction. Then we'll talk about classification of friction, students. There is a certain classification based on friction. Then what? See, in classification of friction, one classification is external friction. Okay. The importance of this is we have to study this classification of external friction. Okay. So that we'll study today. Okay. Just a second, students. That we'll study. Then yes, then summary of today's session. Okay, students, is it good? Are we good to go? So everyone is joining. Most of you have joined. There are certain students who didn't join. It's okay. I hope they'll join in later class. Now, do you remember what we have studied in the last class, students? Let me know in the chat. North Canada students, let me know. Davangere, Ballari students, do you remember what you have studied? Madhya, do you remember? Or have you gone through at least what we have studied in the last class? Okay, good. Point method. Yes, sweetie, very good, very good. Yes, what was it? We talked about, the first thing we talked about was point method. So basically this point method was used for what? To finding velocities. Yes or no? Agar unknown velocities hai, if there are, let's say this is pulley and there is this pulley with moving with velocity vp, and there is this a that was moving with the velocity va upward direction, we wanted vb. Yes or no? In this we said that what was the let's say sign convention we used. Sign convention. What is the sign convention we used, students? Let me know. If string is what? If it is reduced, the length is reduced. If it like feels like length is reduced, yeah, length is reduced of the string, reduced. What of the string? Then what? Mark it with negative sign. And if you feel like if it is what? Elongated or stretch, then you took it as what? Positive. Over here, let me know what is the sign of VA? What was the sign of VA we took? Sign of VA, let me know. Jaldi. That was negative. Very good. And sign of VP was also what? What? It was positive. Sorry, it was positive because it was stretching these points. Yes. So the point was over here. Okay. Yes. Very good, sweetie. Then we got to know what is the value of VB using the calculation, using what and all we got. Yes. When we told that what it is VB, VA minus VA plus VP. Since there are 2 points, there is 1 point and 2 point where it is touching. We got VP and what? Plus, since for calculation I took VB as positive, which is equal to 0. Then using the calculation, we got what? VB as what? VA minus 2 VP. Is it good? This was the, let's say, starting of our session where we explained what was point method. Yeah. Then next, what did we study about? We talked about the concept of what? String constant. What was the concept basically? See, here was a problem that we talked about, but what was the concept basically? Let's say there are 2 masses attached with the string M2. Okay. Let's say these are in the same base. Okay. In the same surface. The surface is same. Okay. Then if I'm applying a force and if it is moving with the velocity, let's say some A, okay, just a second. Not A, okay. A meter per second or B meter per second. Then what did I say? This string at this point, and this point, and this point. What is the velocity, students? What is the velocity? Let me know. Let me know, students. Jaldi. Tirth, let me know. Madhya, Tumkur students, North Canada students. I heard North Canada students, they are little not in the class. So please be active, students. Please let me know. Yes. What was this point? What was the velocity over here, and here? Let me know. If it was B velocity, it is B velocity with which it is moving, this mass. Then along this path, along this string also, it's what? B meter per second. Very good, sweetie. Then if that is the case, this also moved with the velocity of what? B meter per second. Yes or no? So the concept of what string constant says that if the masses are attached, then what? Along the string, the velocity is same. Yes, yes. Very good, Tumko students. So this was the, so based on this concept, we saw that this is what along this point, if this is 5 meter per second, along this point, it is what 5 meter per second. And we saw that it moves with the velocity VB, and what there was a component VB sine 53. Sorry, VB cos 53. I'm writing sine from yesterday. That was cos 53. That was a component. Yes. Then we wrote what VB cos 53 equal to 5. Then based on it, we found what is VB. Yes. Is it good? Yes, students, let me know. Let me know. Let me know. I'll be holding today North Canada students. So let me know. Yes, sweetie. Very good. Okay. Others, Bagalko students, do you remember all these things? Yes, yes. Very good. Others? Badari students, let me know. At least with a thumbs up, okay? Because if there is no interaction, then I can't know whether you are able to understand it or not. Okay, now that's the only reason I asked. Ki, did you guys understand? So if anyone is available over there, please make sure that at least there is a thumbs up or any type of emoticon, so that there is I can know that students are understanding. Okay, okay. Davangere Badari students, please let me know. Okay, good, good, very good, very nice. Madhya, okay, students. Now, if that is the case, then here is a recall question for you guys. You need to find, see, this was a homework question. Over here, what it is saying, the question is saying, basically, over here, this is a ring, okay? This is a ring, and this ring can move up and down. Now, if I'm moving this ring with the velocity V1, so V1 is the velocity of ring, and I'm moving in upward direction. अगर ये upward जाएगा तो ये नीचे जाएगा ना, yes or no? ಇದು ಕೆಳಗೆ ಹೋಗ್ತದಲ್ಲ bas. Now if that is the case, students, please let me know what is the velocity of V2, what is the value of V2. Let me know, students. Jaldi let me know. I'm giving you exactly 2 minutes of time. It's not required also, but I'm giving you 2 minutes of time to make sure that you tell me what is the answer of it. Let me know. Okay, the timer has started. Please let me know, students, and I want everyone to answer it. Jaldi batao. So the velocity is in what? The downward direction, yes, because it will move in this direction, V2. So I need to find out. I need to know what is the velocity V2. YouTube students, let me know what is the velocity. Batao. Tumkur, Ballari, North Canada students. As I told, I'll be making sure that I want answer from North Canada students. Okay. Bagalko students, let me know. Madhya, sweetie. This is very, very easy. It will come in terms of theta. Don't worry, it won't come in terms of value. Okay. It will, the answer will come in terms of theta. So don't worry about it. So last 30 seconds. Okay, last 10 seconds, students. Let me know. No one is answering. No one is answering. What is the issue? What is the issue? Let me know. This is the first time that no one has answered anything in this class, basically. Okay, so I'll try to answer it. Okay, over here, see, over here, you know that there is this V1, what this ring is moving with the velocity V1. Yes, now it is moving in this upward direction. Yeah, okay, very good. No. Madhya, it is not v1 by cos theta. Okay, don't worry. Over here, see, you know that v1 is moving in along this line. Yes, along this direction. Now if this is angle theta, then will there be a component of v1 along this direction, v1 cos theta? Yes or no? If that is the case, along this point, this point, this point, this point, see, over here this string is what? Same string. Along this string, this string is what? One string. Yes or no? So along this point also it will be what? v1 cos theta. Yes or no? Now the v2, we want what? v2, the velocity is v2. So can I write the answer as what? v2 equal to v1 cos theta. Yes or no? And this was the answer, students. That's all. Nothing more. बस इतना ही था. How the students? Let me know. This was your answer. Let me know, students. Let me know in the chat. Yes or no? Students, let me know. At least let me know. Did you? Okay, good. Very good. Very nice. Okay, Madhya, very nice. Very good. Okay. So if you have understood it, then it is very good. Okay. Now, okay. Now, students, they now will be going into concept called what? Friction. Now, what is this friction? Before going ahead, I want to ask in general, what do you think about friction? What do you think about friction? Let's say, okay, don't worry, we'll be talking about what is the definition, what is the exact definition. But according to you, what is friction? और कहाँ आता है ये friction? Let me know. See, over here there is one what? Let's say box, and you know it is trying to move in this direction, right side, and they have told that okay, this is this friction. They have showed the value of f. But what is this exactly friction? Okay, very good, sweetie. Okay, Davangere students, opposing force. Okay. Good for trying. Okay, now let's try to understand it. This friction. Okay, what is this exactly? This friction is. Now, do you remember your Newton's first law of motion? What did it say? It said that if a body is at rest, it will what? It will be at rest. And also, if a body is in motion, what? Uniform motion. If it is in uniform motion, yeah. Okay. Let's talk about the motion, not about the inertia. Okay. No, don't worry. It's okay. Very good for trying. Okay. That's the right answer too. But we'll talk about in terms of motion. Okay. It will be at rest and it will be in motion unless and until there is an external force. If there isn't an external force, the state of motion, the state will be either at rest or at motion. Yes or no? Yes or no, students? Let me know. But the thing is, let's do one thing. Let's try to talk with Newton. Newton said that okay, I'm talking with Newton. I told Newton that okay, if it is moving in a uniform motion, then what? Then it will continue continue in uniform motion. He said that okay, I agree with you. But after some time, I observed that this body came to halt. This body, what? It came to halt or to rest position after some time. I'm like, then if you're saying your first law of motion says that it will continue in what? To continue in that state of motion unless and until there is no external force. But if I see in the object, I can't see an external force. Then how this is possible? Then Newton was like, okay, if you're saying that, will there be any other object where you can say that okay, this is happening? Then I was like, okay, let me take a cycle. Okay, let me take a cycle. Let me take a cycle. I took a cycle. Then what did I do? This cycle was moving with the velocity v along this direction. Okay, मैंने क्या किया? I started pedaling. Okay, I have this pedal. I was sitting in this cycle. Then I was pedaling it and it was moving with the velocity v, some velocity. अगर मैंने उसको पेडल किया और मैंने उस पेडल को छोड़ दिया, लेकिन एक टाइम के बाद what happened? This cycle came to halt. This cycle over here came to halt. this cycle came to halt. What happened? It was moving. Now this cycle came to halt or rest. Now I was like, see, your first law of motion, which says the body will continue to what uh, stay in rest, or let's say it is moving in a uniform motion, it will continue to move unless and until there is no external force. But over here, there is no external force at all. I'm not applying any force, external force. So how this is possible? Now, based on this concept, students, then we came to a concept called friction. That force which what make sure that okay, it is slowing down is due to what? Friction force. Is due to what? Friction force. Did you get it now? How did we arrive at, or let's say the idea of arriving at a friction force? Did you get it, students? Now you'd be asking with me, okay, if that is the case, then Newton's laws of motion won't be valid. You'll be like, Hagidre, if Newton's laws of motion was telling without any friction, then isn't you would be asking, okay, is Newton's law of motion valid or not? The thing is, Newton's laws of motion will be valid, but whenever you are trying to do the FBD, whenever you are trying to do, let's say, if there was a surface with the body of mass m, then if there was a what FBD, then we'll be taking into what when doing FBD, we'll be taking friction into consideration. Friction into consideration. Okay, that's all, nothing else. So element what Newton's laws of motion holds, but over here we are trying to understand it using what? Another force, that is what? Friction force. Let me know, students, did you get it? Okay. Okay, students. Yes, very good. Now, what was happening over here? See, over here, the cycle was moving, or let's say this body was moving. So what was happening exactly over here? There was certain what? Opposing force. There was some opposing force here. But students, always remember, over here, there is a relative motion. There is a relative motion. What is this relative motion? There are two surfaces. One surface is your earth, let's say earth surface, and what? Another is your tire, let's say tire. So whenever there is a relative motion, then there is friction, students. So you can't say that friction is a opposing force. ऐसा नहीं बोल सकते. Only this opposing force arrives, it will arrive only if there is what? Relative motion between the surfaces. Did you get it, students? Let me know in the chat. पता चला अभी? Did you get it? So there was this what? Invisible force. There was this invisible force which was halting or what? Resting, because of which our what? Cycle came to rest. The cycle came to rest. But since there was a relative motion, then only this what? Friction force came into picture. Friction force came into picture, students. Did you get it? So the friction force is basically an opposing force which actually comes into picture when there is what students? Tries to move, like when there is a relative motion in the what? In between the surfaces. Now, if that is the case, then I would ask you one question. If the body is at rest, if this is at rest, will there be any let's say friction force? Let me know. Will there be a friction force? Veer Kumar, welcome to today's session. Madhya, okay, Davangere students, you are saying yes. Let me know why. I'm telling the body is at rest. See, over here, if there was a tendency to motion, if there was a tendency andre, like move tendency idre, then there will be friction. But if there is no motion, if it is at rest, then there is no friction. Because as I said, for a friction, there should be either relative motion or tendency of motion. Andre, if I'm standing like I'm standing over here, and if I'm no slide, yes, Davangere students, yes. So if there was a tendency for me to move, then there is a friction, students. Is it good? Okay. Then if that is the case, when you come into definition of friction, okay, what does it say? Now let's talk about the definition. What? A friction is an opposing force. A friction is an opposing force that comes into picture. What comes into play or picture when one body actually moves? If there is a movement or slides or even tries to move over the surface of another. Okay, did you get it? Did you get it, students? Iga, it is saying that over here, it is saying that what if one body actually moves or even tries to move? Tries to move andre, let's say, Iga, let's say in your home, there is a wardrobe. Wardrobe. Okay, there is a wardrobe. Now, you being so jobless at home, your mom will be like, okay, do one thing. Since you're so jobless at your home, what you do? Move this from this room to, let's say, from this room to this room. Okay, this is room. Now, over here, you will be applying certain force. Obviously, you'll be applying this force to move. But let's say when you're applying this force, you'll be applying starting like little force. Okay, you'll be applying a little force. You'll be applying the force, but it won't move. Now you'll be applying more force, and you try to move it. Okay. Now when you apply more and more force, there is a tendency. This tendency of movement is there. Yes, but it won't move. This tendency is what? Basically controlled by what? Friction. Whenever there is a tendency of movement, students, there is this friction. Basically, the friction will be along the surface. So along the surface, there will be a certain friction. Did you get it now? What does it say? So if there is movement, obviously there will be what? When there is body, when actually movement, there will be a friction. But when it tries to move over the surface, when there is a tendency, tries means tendency over the surface of another body. Okay, did you get it now? Let me know, students. Yes. Now see over here, as I said, there are two things. What is happening? There is a mass and there is a surface. Yes or no? So let me say, if this is a surface and the mass is over here, then will there be any friction? Is a friction available over here? Will there be any friction over here? Let me know. And will there be any friction over here? Let me know in the first point and the second point where there will be friction. Where there will be friction. In the first scenario or in the second scenario? Okay, very good. What? The friction will be in this. The friction won't be here. So can I say, students, friction is a contact force. Can I say? So friction is a contact force. Yes. Janvi, tumko students, let me know. Yes. See, over here there is a movement. Don't worry, there is a uniform movement. Okay. Tumko students. Yes. So always remember, students, what friction is a contact force. Without contact, there is no friction. That means what? With contact, there should be some movement or tendency to move. Tendency to move. Very good, students. Tumko students, I know what you mean by there is no movement, but yeah, let's say if it is moving with the velocity v. Okay. Okay. Good. Very nice. Now, coming the another concept of friction. What does it say? What does the friction of force? The force of friction is the force that develops at the surface of contact of two bodies. As I said, what? If there are two bodies, M, and the mass M, then students, along this surface, sorry, just a second. Along this surface, then there is this friction. The friction is over here. Friction. Is it good? Let me know. Now, there is another thing that I wanted to explain you. Let's take two bodies, okay? Let's take two bodies. Okay? Now, if I'm taking two bodies and it is, okay, just a second. There are two bodies and this is mass M1. Okay, this is A. Sorry, let us take it to be A. Let us take it to be A. Let us take to be B. Okay. Now, the concept that I wanted to explain was, if I'm let me sit at this what A position. Okay. Now, if I apply a force in this direction, then the body A will move. Yes or no? Let me know. If the force is applying in this direction, the body will move with the velocity v. Yes or no? Now, I'm sitting on A and I'll be seeing B, which is in my what? Below me. Now, I'm seeing B and I'm telling B that, okay, don't go. Okay, क्या बोल रहा है? What I'm saying कि मैं A में बैठा हूं और A आगे जा रहा है. Okay, लेकिन जब A आगे जा रहा है, मैं वहां बैठा हूं और मैं नीचे देख रहा हूं, तो मुझे ऐसा लग रहा है कि B जा रहा है ना, B मुझे छोड़ के जा रहा है. तो मैं बोल रहा हूँ B छोड़ के मत जाओ. तो छोड़ के मत जाओ तो क्या होगा? एक फ्रिक्शन फोर्स आएगा. Now this friction force is basically what? Let me know, students. Is basically applied by A, friction force applied by A on B. Yes or no? There'll be a friction force. उसको बोल रहा हूँ. Yes. Now over here, if I'm sitting on B, देखो मैं B में बैठा हूँ और A जा रहा है. अगर A आगे जा रहा है कि नहीं? ये आगे जा रहा है, मैं बोल रहा हूँ A मत जाओ, तो मैं एक फ्रिक्शन फोर्स लगाऊंगा. That is what? On or friction force by B on A. Yes or no? सही है, ये सब सही है. देखो मैंने पहले फर्स्ट आई वाज इन ए, आई वाज सिटिंग ऑन ए, देन आई वाज सीइंग बी, आई एम मूविंग फॉरवर्ड, आई एम लाइक बेसिकली आई एम मूविंग फॉरवर्ड, बट आई एम फीलिंग बी इज मूविंग, सो आई एम टेलिंग बी don't move backward, so I'm applying a friction force, what? Applied by A on B. Similarly, this friction force is applied by B on A. Did you get it, students? Let me know in the chat. Yes or no? Yes or no, students? So if that is the case, can I say this friction force on the body, if there are two bodies, then this exists in pair. Then does it exist in pair, students? So can I say friction force always exists in pair? Can I say it, students? Yes. Okay, very good, very nice. So that is the concept that I wanted to explain. Did you get it now? So friction force will always be what? Will always be in pair. Yes. Oh, okay, good. Madhya, sweetie, let me know. Yes. Did you get the concept now? Yes. Okay. Davangere students, very good. North Canada students, sweetie, very nice. Veer Kumar, let me know. And YouTube live students, let me know. Let me know. Okay. Now, if that is the case, students, now we'll go into different one concept. There is friction in space. Which friction? Veer Kumar, I didn't get you. You mean A friction? Yeah, you can say that. Yes. No, wait. That is what it is. Let's talk about it. That is a different concept in terms. Okay. That is in terms of acceleration that you are applying. Okay. That is a force that is applied. Okay. Okay. See, first thing, I'm sitting over here. Then I'm talking about it. North Canada students. Okay. Sorry. That concept FAB equal to FBA, will be talking about it when we talk about the what? The problems. Okay. Till now, just try to understand that I'm sitting over here. Then this what? This A will apply a friction force along this direction, along here, and this body will apply a friction force on A. That is what? FBA. Okay. Veer Kumar will talk about the friction, air friction, and all. We'll talk about it. Okay. Is it good? Now we are talking about the friction applied by the surface. North Canada students, is it good? Is it good? Is it good? Okay. Now we'll understand the value of frictions and all. Okay, don't worry. So there are different types of frictions also. So based on it, it will we'll try to understand whether it is FAB equal to FBA. Okay. Okay. Good. Now talking about origin of sliding friction. Okay. what is this origin of sliding friction, or why this friction came into picture? Why this friction came into picture? Now, students, let's say we have a table. We have a table and we have a cup of coffee. Okay. Now, I have kept this on the table. And you know that both the surface is what? It has a surface. Now, when you see with the naked eye, students, let me know whether that surface will be visible smoothly, whether the surface will be smooth. Let me know. Let me know, students. Yes, very good. Okay, very nice. But when you zoom in, students, when you zoom in, you will observe that that surface is basically is what? Not smooth, not smooth, not smooth. So what? There are some irregularities. There are some irregularities. Okay. So these basically, whenever you keep one surface upon another, these irregularities, okay, will be something like this. Okay. If this is surface 1 and if this is surface 2, if this is surface 2, okay. So this is surface 2 and this is surface 1. So what is happening over here is the maxima of each surface, the maximum of each surface will be what? Pointing on along what? It will be attached to another maximum of another surface. This is surface 1 and this is surface 2. Yes. Now, students, over here, the point of contact area, the point of contact area, is it very, very small? Yes or no? It is point, right? It is point over here. Yes or no? See over here, this is surface 1 and surface 2. Let's say this is cup of coffee that was kept on the table and its surface, and this was the table. Over here, you saw that there are certain irregularities, and here the irregularities are such a way that what was happening? The highest point of surface 1 was in contact with the highest point of surface 2. Okay. But the point of contact, the area of point of contact is very small. Yes or no? Yes. So when there is contact, there is a force, that is the pressure. That is the pressure that comes into picture. Okay. That pressure is what? Force by area. And this pressure, students, can I say this pressure is very high, or up like 10 to infinity, because this area is very, very small. Yes or no? Because the area is what? Point area. If I'm taking the point area, can I say there is this force that comes into picture, and that is what? Pressure that comes into picture, and that is what? Force by area. And the pressure is very, very high due to the area of contact. Okay. Now, there is this area of contact that is happening, and there is this force. And this force is, students, is what? Force of students. Let me know what is this force? Force of adhesion. Now, this force of adhesion is basically what? It is making this what? This contact, what students? Interlock. They'll get interlocked, and that is a reason there is a friction that comes into picture. That is why when you apply a force, the surface won't move easily. Did you get it now, students? Let me know, students. Did you get an idea now? So what is happening in the surface basically? Okay, did you get it? Yes, sweetie, let me know. Veer Kumar, Davangere students. Okay. Now, okay, as I said, this pressure is basically what? Force by area. As I said, there is high pressure. Yes or no? Now, as I said, this area of contact is very, very small. So can I say it is basically the friction is independent of area? It is independent of area. It is basically what? Independent of area. Now, and also I said that this force is what? Force of adhesion. Now, what is this force of adhesion, students? Due to this force of adhesion only, there is this what? Friction force. There is this friction force. What is this force of adhesion? Can anyone tell me what is this force of adhesion? Let me know. Let me know. What is this force of adhesion? See, this is basically what tells about the force of attraction between the surfaces. Between the surfaces. No, it's not applied force on the object, Damanegare students. Dekho. Have you seen Fevicol? Have you used Fevicol? Have you used Fevicol? Let me know in the chat. Have you used Fevicol? The gum, the glue. This is the glue. If you check the backside of Fevicol, there is a adhesion written. Okay, force of adhesion value. Okay, there is certain value. This is basically it's saying that, like, if there are two surfaces, with what, how much it can attach the surface, basically attach, like a different surface, a different quantity, like a different surface itself. You can connect two different types of surface, right? Type 1 surface, and type 2 surface. Yes. So basically in Fevicol you can use, basically adhesion means how much attraction you can stick those surfaces. Again, there are two surfaces. If you apply gum, yes, if you apply gum, then what you can attach that Fevicol, then you can attach that's two surfaces. So basically adhesion tells about the force of attraction. How much, with what force of attraction you can keep that objects together. Is it good now? Let me know. Yes. So did you get it? The idea of how did we get the friction? How did it come into picture? Let me know, students. Let me know. I'm giving you 2 minutes of time to grasp everything that we have gone now. Okay, Davangere, very good. Let me know in the chat if you have any doubt. Not Canada students, let me know. Okay, very good. Davangere students, you have any doubt, or it's like you are saying it's not clear? Ballari students, I'm not getting any response from Ballari and Bagalkot students. Let me know. Is there any issue? Okay, good. Davangere students, very nice. Others, let me know. Okay, very good, very good. Okay, Ballari students, very nice. Now, if this is the case, then the friction, this friction, जो हम बात कर रहे हैं, अदर ಬಗ್ಗೆ ಮಾತಾಡ್ತಿದ್ದಾರೆ. Understood, sweetie, very nice, very good. Madhiha, let me know. Madhiha is in chat, very nice. Let me know. Okay. Now, when you talk about friction, there is what classification of friction. Now, this classification is done in terms of two types. One is external friction, and then there is what internal friction. Now you know the concept, like external you can understand what is this friction, and internally you can know what is this friction. So anyone can try to guess what is this external friction. What is this external friction is basically tells about. Can anyone guess? It's very easy. Can anyone guess? Can anyone guess? Try to guess at least. Let me know. Okay, let me tell you. Okay, sweetie, very good, very nice. See, this external friction comes into picture when there is movement. When there is movement or tendency to move. Ili tanaka enta maatarthivi adra, that is external friction. So what is this external friction, students? Basically it says which arises if there are two bodies, let's say two bodies, and which is in contact. Basically they are in contact, and what if there is a movement, what each other and try to move, and there is an actual relative motion between them. Okay, if there is what tendency or what actual movement, then what students, then there is this external friction that it comes into picture. Now students, always remember this external friction is also called what? Contact friction. Okay, this is also called contact friction, students. Is it good? Let me know. Let me know, students. Okay, now. Okay, now what the another thing is, what the external friction. What is this external friction? See over here, it says that which arises on account of relative motion between two layers of a liquid. Okay, Iga, let's say you have your water. You have your water. Okay, let's say for consideration, blue color illa. Let's consider this to be your water. Okay, for time being, if there are water, then there are layers. Layer 1, layer 1, layer 2. Yes or no? Whenever there is a movement of water, whenever there is flow of water, okay, there is movement of water, then students, there is this friction that comes into picture between these two layers. Okay, it doesn't mean that it comes only in water. Let's say honey, let's say paste, the toothpaste. Over here, there is this friction that comes into picture. Don't worry, we'll be talking about internal friction in what? Fluid mechanics. Okay, we'll be talking about it in fluid mechanics. Then you'll be understanding clearly what it is. Okay, basically this internal friction is also called as what? Viscosity of liquid. What? This is what basically tells about the viscosity. Viscosity. Is it good? So don't worry, we'll be talking about it in our coming classes. External friction. See, external friction, Badari students, this is nothing. Let's say if there are two surfaces, okay, this is mass M and there is another surface. Okay, this is a surface and this is mass M. Now, if there is a movement, if there is an external force that is applied and there is a movement, or there is a tendency to move. Like if I'm applying for the force on the mass, if I'm applying the force on the mass, and there is this tendency. There is a tendency, there was a not movement, but tendency to move. Then what? There is a friction that arises on the surface of these two bodies. That is called external surface. Bas, or kuch nahi. The external friction is also known as what? Contact friction. Basically, if there is contact, then only there is what? This external friction. So till now, what we were talking about, that is only external friction. But this internal friction comes into picture in terms of what? Liquids. Okay, so fluids. So when you talk about fluid mechanics, we'll be talking about it. Okay, it comes what? In between layers. It comes between what? Between layers of fluid, and it is called what? Viscosity of friction. Let me know, is it clear? Let me know. Let me know, students. Others, okay, very good, sweetie. Davangere students, very nice. North Canada, Tumkur students, Madhya, let me know. Bagalkot students haven't replied yet. Is there any issue? And YouTube live students, welcome to today's session. And if you have any doubt, let me know. Okay, very good. Now, okay. Now, when you talk about external friction, just a second, let me drink some water. Now, when you talk about external friction, this external friction is again classified into three types. One is static friction, another is limiting friction, another is kinetic friction. See, these starting and limiting frictions are related. Okay, when you understand static friction, you'll understand it. Okay, now talking about static friction, when you hear the word static, so what does which comes into mind? What does exactly it says? Can anyone say? Can anyone say, students? When does, okay, the question is, when does this static friction will arrive? Can anyone say? Okay, like when you hear static, you'll be like at rest. Okay, but not exactly at rest, students. See, the static friction will arrive when there is what tendency of motion. Tendency of motion. Motion ಆಗ್ಲೇಬೇಕು ಅಂತಿಲ್ಲ, but what, when there is a tendency, it is not at rest, students. When there is a tendency of motion, then what, static friction will arrive. Static friction won't be there when there is what, relative motion. Is it good? When there is relative motion, there won't be static friction. But what, students? When there is a tendency of motion, then there is what, static friction. Yes. Do you remember the wardrobe example? If I want to move this, when there was a tendency of motion, then there was this what, this static friction comes into picture. Is it good? Let me know, students. Let me know. Yes. Let me know. Yes, very good. Others, let me know. Yes, very good. Now, talking about symbol. Okay, the symbol of static friction is what? What is here? Fs. This is the static friction symbol. Okay, now, is there any formula? To calculate static friction? There is no formula. To find the static friction, because, students, because I'll tell you why. The formula is not there, because the static friction is what, is variable. Now, what does this variable mean? Now, students, let's take, there is a surface of 5 kg. Now, if I'm applying a force is equal to 1 Newton, guess whether there is a movement. When I applied F is equal to 1 Newton, was there any movement? Students? Let me know. If I'm applying a 1 Newton force, very little force, very little, will there be any movement? No. Yes. Okay. So it does. What does it mean? There is this friction that is being applied. Okay, there is this friction. Yes, due to which it doesn't move. If I apply 1 Newton, 2 Newton, let's say little more force, there is no movement. Now, if I continue, let's say for example, I am applying up to 9 Newton. Okay, and there was no no movement up to 9 Newton of force. But once I applied force is equal to 10 Newton, when I applied force is equal to 10 Newton, then there was what? There was movement of force. Okay, there was this what? Movement, tendency of movement. Now, students, now if that is the case, can I say there is a limit up to which the static friction applies? There is a limit up to which there is this static friction applies. Can I tell? Can I know? Yes or no, students? So there was movement. Okay, there was movement. Basically, up to here there was what? Tendency of movement. But it didn't move at all. Okay, let me know. So can I tell that the static friction has a limit? So what was the limit, student? It was basically from 0 to, let's say, F S up to a maximum value. Yes or no? See, once I applied, the force is equal to 10 Newton, then the body what? Moved. Then the body moved. Yes or no? See, first there was a body. I applied 1 Newton. It didn't move. Like there was a tendency to movement, but it didn't move. 2 Newton, it didn't move. I applied 9 Newton, but it didn't move at all. But once I applied 10 Newton, what? There was a movement, students. What? There was a surprise. Okay, there was a movement. So can I say up to certain limit, it doesn't move. But once there was a maximum what force up to a limit, what? There up to a limit, let's say, just a second, up to a limit, if this what if this force is crossed, if this force cross this maximum static force, then what? There is a movement. Can I tell, students? Let me know in the chat, yes or no. Let me know, yes or no. Okay, others, let me know, did you understand it? Yes. Okay, very good. Now, can I say then, if applied force is less than F what? Fs max, then body won't move. Yes. Then, if the applied force is greater than Fs max, then can I say what? The body will move. Yes, obviously it will move. Yes or no, students? Yes or no? Yeah. Yes. Now, I told you that there is no formula for Fs, what? Static friction. But students, there is a formula for what? Fs max. What is this formula? Now, let us try to find this formula. Let me ask you, let's say there was a book over here. This is a book and it is kept on a surface. Okay. Now, if I apply a small force, F small force, अगर मैंने थोड़ा, एक बुक है ना, एक नॉर्मल बुक है, मैंने उस पर एक थोड़ा फोर्स लगाया तो वो मूवमेंट होगा ना? yes or no? let me ask you, yes or no? थोड़ा अगर फोर्स लगाया तो मूवमेंट होगा? yes, let me know, students. Yes or no? Students, let me know in the chat. जल्दी बताओ. Yes, very good. Now, if I apply a force from here and apply a force from here, will the book move? If I apply a strong force, that's a normal force, will the block move? If I apply a small force, will the block move? No, right? So can I say that this what this the static friction, the maximum static friction is basically what? Is proportional to what? The normal force. Yes, where n is the what? The normal force. So students, when you remove this normal, what? The proportionality constant, max is proportional to n, then you get Fs max is equal to what? Mu into n. This is the maximum formula for maximum static friction, students. Is it good? Let me know in the chat. Let me know. And what is mu, students? What is mu? Let me know. Coefficient of static friction. Coefficient of static friction. Is it good, students? Let me know. Is there any doubt? In the meantime, students, I'm giving you 1 minute of time to grasp everything. In the meantime, please answer the NPS too. I'm launching the NPS. Please answer the NPS. Let me know. Okay, others. Davangere students have said, Sweetie has said. Let me know in the chat. North Kannada, Tumkur, Madiha, Ballari students, let me know. Is there any issue or is there any doubt? Let me know. Okay, good. Very nice. And yeah, see, Always remember, students, I'm open to any doubts. If you have any doubts, let me know. And if you don't understand the concept, students, stop me there. Stop me right there. Tell that, sir, I didn't get, like, I'll be very happy to explain you anytime. Okay. I'll be happy to explain you again and again and again. See, in my class, there is one thing, okay. One thing you need to understand is, even if you have a doubt, which is very simple, very simple. Any student, okay, very simple doubt. Simple doubt means what? If you ask 1 plus 1 is 2 or not, that doubt is also is fine for me, okay? Because see, my work is to make sure that you understand every concept. Yes. Tumku students will be doing numericals based on this. Okay, don't worry. We'll be doing tomorrow as there is less amount of time today. Don't worry. See, the thing is, I'm doing lesser numericals is because once the concept is set, then we can dive into what JW and need questions. Yes or no? Then we can dive into lot of problems. Once the concept is set, then everything will be very clear. Is it good? Yes. So that is why. Tumku students, let me know. So without setting a concept, then you can not understand it. Yes. Yes, if that is the case, students, so please answer the NPS, everyone. Okay, no problem. See, okay, here is a homework question for you guys. Okay, here is a homework question for you guys. Let's say this is homework question. Homework. Try it. Okay, even if you don't succeed in it, don't worry. Don't worry. Alright, thank you. Thank you, Davangere students. See, this is what, if you give so much motivation, right? I'll be very happy to do anytime, okay? Anything for you. Now, the question says, there is a block, okay? There is a block which is of 5 kg. And I applied a force of 8 Newton. And there is a coefficient of friction, static friction as what, 0.2. Now, I want what is Fs max. I want what is Fs max. And I want the gist of it, okay? Is it good? Students, this is a homework, 5 kg mass, there is a force of 8 Newton, and students, what? Fs max. I want to know whether the body will move or not, okay? I want to know whether the body will move or not. Good? Okay. So if that is the case, students, that's all for today. So with that, let's talk about the summary. What did we talk about today? First, there was recall about previous sessions. Then we talked about friction. In that, we came to know that what? There should be a relative motion. Relative motion. Then there is, for this relative motion, there is this opposition. Yes? If there is no relative motion, then there is no opposition. Then you can't say that friction comes due to what? You can directly can't say friction is the opposing force. You can't say that. Unless and until there is a relative motion, then there is opposition to the relative motion, then the friction arrival. Then we saw that there is this external friction and there is this internal friction. And this external friction is divided into what? Static. What is a limiting friction? And what is the last friction? Let me know in the chat. What is the last friction, students? Relative friction. Yes, relative. So, and we saw F is equal to mu into N. This was the important. This is very, very important. Yes, Davangere students. Thank you. So that's all for students. Thank you for attending. Okay. If you have any doubt, you can stop. Okay. Very good, Tumkur students. Very good. Okay, sweetie. Just a second. Okay. Sweetie, what was the question? Okay. Let me check the Telegram now. Okay. So students in YouTube, take care. Okay. Bye bye. Take care.